Hi everybody, we'll continue solving exercise number 7. So we have a function f of x equals to x minus 1 plus 4 over x minus 2. In the first part we find the domain of definition, and in the second part we prove that the straight line of equation x equals 2 is a vertical asymptote, and also we find the limit at plus and minus infinity of the function f of x. So now part 4 shows that the straight line y equal x minus 1 is an asymptote. In other words, because the equation of that straight line is a relation between x and y, so this straight line should be an oblique asymptote. Then to prove a line is an oblique asymptote, the first step is to evaluate and simplify the expression of f of x minus yd. So replace first f of x by its expression and yd by its equation. So x minus 1 plus 4 over x minus 2 minus the equation of the straight line, which is x minus 1. So this is a direct simplification. X minus 1 minus x minus 1 cancel each other, and it remains simplified expression as 4 over x minus 2. Here I use the first expression of x. You can use the second one, and you must get the same answer. So a second step is to find the limit at plus and minus infinity of this simplified expression. So the limit at plus or minus infinity to 4 over x minus 2, we replace x by plus or minus infinity, so 4 over plus or minus infinity, which is equals to 0. Any number over infinity is 0. Then you can conclude that this straight line is an oblique asymptote. Part 5 is to study the relative position between the curve C and the straight line D. The first step is to draw a sign table for the simplified expression of fx minus yd. So fx minus yd is equals to 4 over x minus 2. So you draw a table. First you plug the domain of definition, which is between minus infinity 2 and between 2 plus infinity. Take any number between 2 and plus infinity, let's say 3. Then replace x by 3 in the expression of fx minus y. You will get a positive number. And also take, let's say, 0 between minus infinity and 2, replace x by 0 in the expression of x minus yd, you will get a negative number. So the sign of x minus y is negative between minus infinity and plus 2, and the sign of x minus y is yd is positive between 2 and plus infinity. When the sign is negative, then the curve C should be below the straight line D. And when the sign is positive, then the curve C should be above the straight line D. So now part 6. First of all, we're required to find the derivative f prime of x. So you can use one of the two expressions of f of x, but it's easier to use the second one. So I will use the second. The derivative, you must use the formula u over v, so u prime v minus v prime u over v squared. U is the expression of the numerator, which is x squared minus 3x plus 6, and v is x minus 2. U prime, which is the derivative of the numerator expression, is 2x minus 3, and the 2x minus 3, yes. And the derivative of the denominator expression x minus 2 is plus 1. So replace u prime, which is 2x minus 3, x minus 2, minus 1 into x squared minus 3x plus 6. Then simplify over v squared. Now expand and reduce the numerator expression, and you will get x squared minus 4x over x minus 2 squared. Then take x as a common in the numerator expression, so you will get x into x minus 4. As an homework, draw the table of variation and try to do part 7 and 8 and 9.